Hello, welcome back to the channel. So today we are solving longest subarray with maximum bitwise n. So the question is like this. We're given an array of integer and we want to return the length of the longest subarray that has the maximum possible bitwise n. So we return the length of it instead of the maximum possible bitwise. So let's look at this array 1, 2, 3, 3, and 2, 2. So the maximum possible bitwise is actually at 3. So the longest subarray is a length of 2. And it happens on this one as well. So there's 1, 2, 3, 4, and then we can see the maximum possible bitwise of this n is actually 4. So we return the length to be 1. So there's actually a interesting fact about this, but let's just dive into what a n is. So let's say I have 1 and 2, right? So basically n means you want both condition to be 1 to be 1. This is like when you have a while loop while a greater than 0 and b greater than 0. So you want both of this to be true to going into the while loop. So this is the same thing here. You want both of them to be to be 1 in order to come up with something 1. So in this case, you have 1 and 2, which will just give you 0 in this case, right? But let's say you have 2 and 3. Just in the case where we have just now, right? We have this 1, 2, 3, 3, 2, 2. So we will have to encounter this case of 1 and 2 and then 2 and 3, right? So when you have 2 and 3, this 0, 1 will give you 0, and then 1 and 1 will give you 1. So when you have 2 and 3, it actually gives you 2. So if you haven't found a pattern yet, yeah, let's look at it again. So let's say I have so I don't like the All right, let's look at another example again. So when we have a let's say 7, right? And 15. So when we have 15 and 7, it will give you 7, right? If you have 15 and 14, this will give you 14. So this means that also we have the case of 2 and 1, right? So 2 and 1 will give you 0. So this tells you that when you have a larger number, when you end with something less than you, then the number will be strictly less than whatever you are because you're the larger number. So let's say 15 and 7, right? So you can find out that actually you have a leading one that they do not have. They just have leading zeros. So whenever this 0 and 1 hit, it will make it to be 0. So if you have something like that, you'll always become lower, right? You always become less than the value of yourself. Um, when you are 14 and 15, right? Let's say you're 14, something is larger than you, then you might not get that from yourself, but you look at this 15 and find out that well actually whatever you get is actually strictly less than the larger number of this two, which you become 14. Or you can say, because it's 2 and 1, if you're 1, you can say you get something less than or equals to yourself if you're the minimum one, but you're the larger one, you get strictly less than whatever you are. So in this case, if we want to get a bitwise maximum possible bitwise n, you kind of don't want to do it with someone else, right? Let's say you have like 15. Let's say you have an array of let's do it in color. Let's say you have an array of 1, 15, and 14. I know this 2 will give you 14, but why don't you just live by yourself, right? If you just stay with a subarray size of 1, and then you just return output 1 of the length, and then your bitwise n will be 15, right? This is the largest one, right? In this case. So the problem here is like when you see there's 1, 2, 3, 3, 2, 2 thing just now, we're just trying to find a maximum of it. We're trying to find a maximum of it, and then we count how many consecutive maximum we have. And then if we hit something else, this 3 and 2 will give you 2, which we don't want it. Like this thing will give you 3. So when we find something lower than that, we just like, oh fine, we found it, so we put a 2 in our answer. Unless we found something larger at the back. Let's say we find like a 4 right here, right? Then we want to, instead of output a length of 2, we just want to output a length of 1 because this 4 itself gives you the largest possible bitwise, which is 4. So the whole idea here is just trying to find which one is the largest number, and then just find how many consecutive largest number it contains. If in this case, then you want to output 4. All right, just let's dive into the code. So initially, I'll just do a maximum to keep track what's the maximum value it is. And then longest just mean what's the longest value. Longest like subarray. And then I just set current length equals to 0. So current length is just keeping track of what is like that thing you are. And then we just want to keeping track of your current length if you hit the max, right? So for num in nums, so if num is less than maximum. Also, I forgot to mention why I can just set maximum equals to 0 instead of some sort of negative. I think I'm not sure how to handle a negative binary, but in this case, they already tell you that the nums is just in between 1 to 10 to the power 6. So you can just set maximum equals 0. And if the num is less than maximum, we can just reset the current length to be equal to 0. The other case is num is strictly greater than maximum, right? If it's strictly greater than maximum, we want to set maximum equals to this num. And then current length, we'll set current length to 1 because we just found this first value. Otherwise, if they're equal, and then I just want to increase my current length by 1. All right. And before we end each of the for loop, we just want to update the longest to be equal to max of the longest and the current length. And then we return longest. So if you run this will tell you that you get accepted for this 2 given tasks. But let's add another case where let's say I have 3 and 3 and 3 and 3 and 3. So this will return a 5, right? But what if I put a 5 at the end? So this should just give you 1 instead of 5, right? So let's see what the current solution will give you. So the current solution will give you output 5 instead of 1. Let's see if I can move it here. All right. This is because when I do this, right, I do longest equals to max of the longest and the current length. So if I found, let's say 3 is actually the max, right? It's the max. So I'll just, in the first entering, this will set the current length to be 1 and then increase it by 2, 3, 4, and 5. So the longest will be equals to the max of current length and longest. So now the longest is actually updated to be 5. When I enter 5 again in this place, and then we'll just tell you that, oh, this is larger, and then we set current length to be equals to 1. So when we compare 5 and 1, of course 5 is greater than 1, so this will just keep this 5 right here. So instead, when we find something that's longer than it, we want to reset the longest to be equals to 0. So whenever it comes to the current length again, they're comparing current length with 0, so it won't have this thing happen. So if I run this again, and it should pass this test. So let's submit this, and it's accepted, right? It's right here. So this runtime will just be of n, which is the length of the nums, because we just need to go through this once. All right. So thank you for watching, and then I'll see you in the next video.